Hi everyone, welcome back to my channel. So in this video, we are going to deep dive on the topic of graph. So I am going to teach all the concepts in such a way that you will never forget all the basic concepts of graph. So please watch this video till the end and I guarantee that you will get all those concepts and you will never forget, right? So in this video, I am going to teach all the real life application of graph. How do you represent a graph? How do you traverse a graph? And we are also going to write a code for both breadth first search and depth first search with a real lifetime example. Okay, so let's get started. So basically you might not know, but in your day-to-day life you always use graph, right? Let's say for example, while running Facebook, you might send a friend request to someone, right? And when you become friend of each other, right? So this is an example of undirected graph. Like you follow your friend and your friend follow you, right? And for example, you also use Instagram, right? But here you might follow B, and there is a chance that B might not follow you, right? So this is a example of directed graph. Okay, and you have also seen, like you might have traveled uh, through airport with I mean from airplane from one place to another place. So this is also kind of graph, like, and there is a distance between them. So let's say for example you are going from Delhi to Bangalore, and average distance is around 2000 kilometers. So this is an example of weighted graph. Edge have the meaning, they carry the data, right? And also there is a concept called cycle graph. For example, let's say you there is some testing going on in flight, right, from Bangalore. Again it is coming back to Bangalore to traversing different area. So this is a kind of cycle graph. And you also use, I think, Google Map in day to day life. So this is the best example of graph, as every intersection is node and every edge is road with distance, right? So this is an example of weighted and undirected graph. So this was the real lifetime example we use day to day in our life, but you might not know. So internally we use a lot of graph while running any application or in mobile apps, right? And okay, so now let's start with the topic. How do you represent a graph, right? So let's say, for example, let me show you. Let's say there is place called A, right? And let's say this is a Google map, ABC. So this is B place, this is C, A, right? So A is connected to B and B is connected to A. Similarly, A is connected to C and C is connected to A. So this is visible, right? We are seeing this graph as connected between A, B, and C. But how do you represent this connection in code, right? Because without representing in code, you can't do any further process, right? So there are two ways in which you can represent this graph, right? So the first one is adjacency matrix and the second one is adjacency list. So let's understand each one of those. When should you use adjacency matrix and when should you use adjacency list? So basically in adjacency matrix you see, so the row is divided into ABC and the column is divided into ABC. There are 3 points, right? So let's say A is connected to B. So here you can see A is connected to B, and where the intersection happened, there we are representing as 1, and if it is not happening, there we are representing as 0 or empty. So again B is connected to A similarly, right? So B is connected to A, so here we can see we are representing it as intersection point as 1. Similarly A is connected to C and C is connected to A. So A is connected to C, so 1. Again C is connected to A, so it is 1. Okay, so what is the problem here is that since every node is not connected with each other, so here you can see there are a lot of spaces which are vacant, right? So when you traverse through them, uh, we are basically using extra time and extra space, right? Most spaces are wasted since we are not utilizing the whole space of adjacency matrix. So in this scenario, adjacency matrix approach is not good, right? Because it takes quadratic space and time complexity. uh, to insert a new node. So that's why, since there are three nodes, only two nodes are connected with each other. So here the alternative approach is adjacency list. So basically, adjacency list is like a key pair. Key pair, basically we represent a graph as a key pair value. Each item has its own array of neighbors, right, which make it fast to traverse. For example, this a, actually we represent all those point as a key, and again a is connected to bc, right? So all the destination point is connected as a value. So we represent graph as a key pair value. So in this way we can represent our graph. Now let's say we have already represented our graph. Now we need to traverse through them, right? So how can we do that? So let's see how you can traverse a graph. So basically there are two ways. Again, there are two ways to traverse a graph. So there were two ways to represent a graph. Now again, there are two ways to traverse a graph. Let's say you want to go from A to C or B to C or B to B, right? You want to traverse and check if C is connected to A or not. So this kind of scenario, to solve this kind of scenario, we have to traverse a graph, right? So there are two ways. The first one is depth first search. So basically, DFS is a recursive approach, and basically it uses a stack internally. And how it traverses is, let's say you have different various nodes, right? 0 1, and let's say 0 5. Here again there are a lot of, let's say, but here for example I am showing. So it will go to first children, right? And it goes deep dive till it didn't find anything or certain condition is met, right? So it is not going from zero, it is not going to all the nodes, it is going to its one children, and it is going again deep dive into that. So once it finds dead end condition or any not for the node is present, so it backtrack and again go to other node, right? So first of all it deep dive from first node till the end node, and again after that it backtrack and go to another node. And if say there are another branch here, let's say for example, let's say here 5, right? So after traversing all these, then again it backtrack to 0 and then it goes to 5, right? So first of all it goes deep dive by nesting to all the nodes till the condition is met. Then it backtrack. So the code is like, let's say we have a function visit, we check if it is visited or not, and again we call recursively those functions. We will see this logic while implementing real-time application, okay, later on. So now this was the first approach to traverse a graph. Now let's move to second approach. So this is the breadth first search. So this is the second approach. This is basically iterative approach, and it uses queue. Queue basically is a data structure which implements first in first out. So basically what it does, it traverses level by level. It don't go nested deeply, it traverses by level. For example, let's say if we start from node 0, so it don't go to sorry, let's say if we start from node 0, so what it will do, it go to 2 1, and after that it will go to 2, traverse to 2. It don't go to 3 after 1, because this was the case of DFS. But in BFS, it is not like that. It traverses level by level. At same node, at same height, it traverses that all. Again, it moves to next level and traverses all the nodes on that level. So basically, it uses queue, and basically it dequeue and check and again run the loop on that, check the destination. So we are going to cover this logic while implementing real life time example. Okay. So now, since we have covered how we represent a graph and how we traverse a graph, now it's time for implementation, right? So uh, which is the main thing here. So let's say I have included a real lifetime example. For example, let's say we are going to implement a flight connection between airports. For example, in India there are a lot of airports: Bangalore, Bombay, Delhi, right? So what we are going to do, we are going to implement a flight connection between airports. In this case, every airport is a node. Every airport is a node, and the edge represents whether or not you can fly from one airport to another. Edge could contain additional info like kilometers between two airports, which will be case of weighted graph. The routes between two airports could be one way or two way. When they go one way, we have directed graph. If they go both way, it's an undirected graph. For this demo, basically, we will try to keep things simple. We'll make an undirected graph, assuming that when an airplane has a route, it can fly back and forth between the two airports. It will be unweighted so that route between airports don't carry any additional data, and we assume cycles are not possible. We are going to just make things simple, and we are considering that it is undirected graph, no cycles are present, and it is unweighted graph, right? So the question is, I will try to make it simple. So you are basically given in terms of code array of airports, and you are also given routes between them. So this is the array of airports: Bangalore, Bombay, Delhi, Goa, Jaipur, Hyderabad, Trivandrum, Calcutta, Cochin, and Guwahati, right? And here you are given routes like these are the routes that exist between these airports. So you are given two things: airports and routes. So by visually, let's visualize it first. So I have drawn this diagram here. Here you can see from Delhi there are four connections to Bangalore, Bombay, Cochin, again Guwahati, right? So I have drawn this diagram from this given route, just for visualization, right? So now we have to like, so there are so let's go to question. So yeah, basically you have to check is there any route between Goa and Bombay, right? So you are given this problem, you are given this data, and you have to check is there any route present between Bombay and Goa, right? So visually you can see there is a route Bombay to Hyderabad, Hyderabad to Jaipur, Jaipur to Goa. But let's do with the help of code to check if there is route that is available between Bombay to Goa. Okay. So before proceeding any graph problem, first of all, as I have told you, you have to first represent a graph. Then you have to basically, let me tell you here. Yeah, first of all, you have to represent a graph in terms of adjacency matrix or adjacency list. Then you have to traverse a graph. So here yeah, so here you can see there are almost 10 airports. So if you try to connect all airports to each other, it will be very large number of routes, right? 10 to power, I think 10 into 10 it will be 100, but here we are given in 5, 6, 7, 8, almost 10 routes, right? So here if we try to represent in terms of adjacency matrix, so lots of space will be wasted because all the routes are not, I mean all the nodes are not connected to each other, right? Because the maximum possibility will be like we can connect Bangalore to all the airports, again Bombay to all the airports, right? But here it is not the case. So if we try to represent it in terms of adjacency matrix, so it will not be optimal solution. So that's why we are moving to adjacency list, right? And here key is name of airport and value is array of edges or another airport connected to, right? So basically here we will be choosing adjacency list. uh, mm, we'll be giving preference to adjacency list instead of adjacency matrix, right? Why? Because here we will like lots of space will be not covered, and it will take more time complexity and space complexity, right? So now let's this so we have decided how to represent a graph. Now we will move to how to traverse a graph. Okay. So here what I have done, Let me show you. So here, graph is nothing but a, you can say, object, or you can say a two-dimensional array. You can represent in different way. So what I have done here I have taken variable adjacency list, and I have initialized a map. Map is a JavaScript. I mean, it's a data structure. Map, it provides a various feature like map.set, map.get. That's why I'm using map instead of object. So here I have defined two functions. Since we have airport and we have routes, it is given in the problem. So I have created a map, and after that I have created a two function, one to add node and another to add edge. So here you can see, here I have created a function add node. So in this function I will be providing airport, and it will be setting that airport uh, in this adjacency list. So here you can see adjacency list dot set airport, and I'm initializing its destination as, for now I'm initializing its destination as empty array. So here you can see what I'm doing. So here airport, let's say airport is Bombay. So A will be Bombay and BC will be destination from Bombay, right? So for now, I'm not traversing, so I'm initializing with empty array. Now I have to add edges, right? So I will be giving two variable to this function, that is function add edge, origin and destination, right? So in adjacency list, what I will do, I will get the origin and push the destination, and it will be in both way, not in a single way, right? For origin there will be destination, and for destination there will be origin. That's why I'm pushing this two times in adjacency list. For example, here there is A, right? So in A, there are two destinations B and C. Similarly, B has, if we consider B as a key, so destination will be A, right? So it will be in both ways since it is undirected graph. So I have defined two functions. Now what I will try to do, I will try to create a graph. So how we can do, we are given two things in problem. One is route and one is airport and another is routes. So I will iterate over each airports and run this function. So what it will do, it will basically assign each airport to its destination as an empty array. So it will do like BLR Bombay is an object. I mean, it will do, yeah. So it will assign for each Bangalore, for each this airport, destination is empty array. And after that I am running a loop on routes. This is routes, I'm running on each array and pushing that route and calling this function add edge, and I'm destructuring that. So I'm getting from this route, from, let's say, for I is equal to 0, I'm getting BLR and Delhi, right? So BLR is origin, Delhi is destination, right? So I'm passing to this that two, by destructuring I'm passing that two variable to this function add edge, origin and destination. So at the end, if you try to print it, it will become like this. Let me show you. Yeah. So this is the code that I have explained here. So basically, if you try to print that, look, I have tried to print this adjacency list. So it will be displayed like this. For Bangalore, there will be destination will be Delhi. So it will be so these key are the origin, and these values are the destinations, which is represented as array. Okay, for Bangalore, the destination is Delhi, and again for Delhi, here you can see where is Delhi. Delhi, the destination is Bangalore. So it is undirected, so it will be in both way, right? So here, what we have done, we have represented a graph, right, in terms of code. So what is this? This is object map, right? So here we have created a map. Now, our question was to find a route between Goa and Bombay, right? So now the traversal comes here. So now there are two ways we can approach this. Either we can use depth first search, or we can use breadth first search. So generally we use BFS when we try to find all the pair, right? if we have to find all the pair or connection between two airports, we can use BFS. But since we have to find one route between Goa and Bombay, so the DFS will be a better approach, right? If you have to find all the possible connection, so I think for that we can go with the BFS. And again, if we want to find a connection, so we can go with DFS or BFS. So here, when, let's say, I mean, we will do in both way. We'll also cover BFS and DFS, okay, for to understand you how we approach this problem. So now we have already represented a graph, and we need to traverse. For traversal, we need to use either BFS algorithm or DFS algorithm. First, let's use BFS algorithm. Okay, so in BFS, what we do, we need to start from any starting node. Since we have to visit from Goa to Bombay or Bombay to Goa, so I will be considering starting node as Bombay, right? And for in breadth first search, I have already told you we use Q and it is iterative approach, right? So what we do basically, we push uh, the point from where we are starting, for example Bombay, and we initialize in array, right? And we consider it as a queue. Now we run the while loop until the queue is not empty. So if there are any elements in the queue, we will keep on running this loop, and we try to take the uh, uh, it is QE since it follows first in first out. So let's say I have pushed Bombay here, so I will get the Bombay as a, I mean, in the airport I will get the value as Bombay. Now from this adjacency list, I will try to get all the destination uh, for the origin Bombay. So for Bombay, there are two, like Hyderabad and Delhi, right? So in destination, I will get the Hyderabad and Delhi. Now I have gotten two airport, which is the destination of Bombay. Now I'll try to run the loop on that airport. So here I'm doing the same. For const destination of destinations, I'm trying to push that destination, that is Hyderabad and Delhi, right? So here I will to push Hyderabad in the first iteration, and I will also check if Goa is not, if destination is Goa or not, since we have to find uh, route between, I mean, we have to find, you have to check if the route between Bombay and Goa is available or not, right? So we have already started with Bombay, and we will check the destination as Goa. So if destination is Goa is available, we will log it, found it. Else we'll keep on pushing and keep on checking the queue length, right? So in this way, it will traverse level by level. But here there is a problem. What is the problem? The problem is, I will show you. So the problem is that if I the this is the BFS algorithm. If I try to run this, let's see the output. Yeah, let's see, there are infinite log that is getting printed, right? Why it is so? It is printing infinite because this queue is never getting empty. Here you can see this queue is never getting empty, because once you are traversing, right, from Bangalore to Delhi, again we are traversing from Delhi to Bangalore. So I mean, it will be keep on going, so we are not checking if any node is visited or not, right? So it will keep on going and running infinite loop, because we are not tracking the visited node. So for that we need to track the visited node, okay? Otherwise you will be in infinite loop. So here I will uncomment the break, so now it will be fine. So what we do to track the visited node, basically we can create a set is also a data structure in JavaScript for storing unique value. So here we can define set, that is const visited is equal to new set. And here in condition, inside this for loop we can check if it is if that set has a destination. If it has not destination, then only we will be pushing in the queue that destination, and we will be also pushing in the visited as add destination, right? So what we'll be doing, apart from pushing in the queue, we will also be adding in the visited set, so that next time uh, uh, the queue will not traversing to that node. Okay, so this was the BFS algorithm. We will traverse like level by level, and now let's go to DFS. Okay, so this is the DFS part. So in DFS is basically recursive. We traverse recursively, we call that function again and again, and it uses a stack data structure. So basically in DFS we pass the starting node and also the visited, as we have discussed, to track the node that we have visited or not. So here first of all we mark that a node is visited, and we also get the all the destination node from adjacency list by passing the initial node. For example, Bombay. So we'll get again this all the destination node, and like Hyderabad and Delhi. Now let's see what happened. I will I will be running loop on that Hyderabad and Delhi destination, and I will check if the destination is Goa. I will log it and return. Else, if the destination is not present, then what I will do, I will be checking in the visited. If it is not present, then I will be running again DFS recursive. I will calling this function recursively by passing the destination. For example, I will be passing this Hyderabad, right, and also passing this visited to check if that node is visited or not, so that the it will not run indefinitely. So again Hyderabad, again it will pass this Jaipur, again Jaipur, then Goa. So here it will find Goa, then it will return from here. It will return from here, right? So this is a recursive approach, and first search was iterative approach. So here at the end, let's try to find the time and space complexity for both approaches. So here basically what we are doing, we are basically visiting each node, right? In DFS and BFS, we are visiting basically each node and edges. So the time complexity will be big O of V plus C, where V is the vertex and E is the edges, node plus edges, because we are visiting every node and edge once, right? And what will be the space complexity? So the space complexity will be like big O of node, because a stack space in worst case recursion will be big O of vertex, and also in case of BFS, Q can hold up to V nodes in worst case, right? It can hold up to total number of nodes as a V, whatever the vertex is there. And also similarly for a stack, for, I mean, if you find, if you interviewer try to get the time and space complexity from a logic, then you should always consider the worst case scenario for that. So here in BFS and DFS, the worst case scenario will be number of nodes, and time complexity will be nodes plus edges. So this was the overall deep dive into graph, and how we represent a graph, how we traverse, and how we find a route if it is available or not. So there can be numerous problem from this core concept. Hope you like this video. If you like, then please comment and also subscribe to the channel. And if you want to get detailed video on any other topic, please put a comment in the, and yeah, see you in the next video. Bye bye.